Esteemed participants, welcome back. We have on stage with us Mr. Chris Van Tuin, who will deliver a speech entitled A Security State of Mind, Continuous Security for Containers in DevOps. Mr. Van Tuin, please.
Thank you. Good afternoon, everyone. My name is Chris Van Tuin, Chief Technologist for the Western region at Red Hat, and I've been with Red Hat for about 11 years, working with strategic partners and customers, primarily in Silicon Valley, who are adopting emerging technologies. And certainly one of the hot topics with our customers is around Docker and containers, and also the security implications with implementing them in a DevOps type of environment. And so in today's talk, I'm going to talk about some of the industry drivers around containers, as well as why Linux containers, what are they from a technical perspective, talk a little bit about the security implications, especially in the enterprise setting, and then also talk about implementing continuous security in a DevOps type of environment. Feel free to reach out in terms of questions at the end of the talk. We have a short amount of time, and I'll be around as well. So some of the industry drivers, I saw this quote, 40% of the Fortune 500 on the S&P in the US will not exist in 10 years. And certainly you can either subscribe to that or not, but one of the things I think certainly many people have seen across a variety of industries is how software is transforming them. And Mark Andreessen certainly had the foresight several years ago about how software is eating the world. And does anybody recognize what this is a picture of? Right, this is the Tesla automobile factory. And the reason I show this is not only is software automating the production of these vehicles, but software is a big part of these vehicles after they leave the dealer lot. Right, for the first time, I can actually go to a dealer's lot, drive off with a car that I know actually will get better over time. Because in 6, 12, 18 months, there'll be software updates that either improve the 0 to 60 time, improve the self-driving or the applications in the car, or even better, when there's a vehicle recall, some of the problems can be addressed via software updates, saving Tesla millions of dollars versus their competitors. And what happens to companies that stop innovating and rest on their laurels? Well, I used to live in San Francisco, and one of the huge impacts there was several years ago when Uber and Lyft, the ride-sharing companies, entered the market. The San Francisco taxi industry saw a decline in 65% of the ridership over several years. Right? They used to average over 1,500 rides a month. It has since plummeted to around 500. And it's because of the introduction not only of lower rates, but also software mobile application that improved the user experience in terms of being able to request a ride and knowing when it would show up so I don't miss my 8 a.m. flight in the morning, as well as it had turn-by-turn directions, so I knew that they were not going the long way or the wrong way when I was in an unfamiliar area of a town. And when I got to my destination, I didn't have to worry about whether I had cash or whether the credit card machine would actually work, because it would automatically deduct from my electronic account. And it's not just a better customer experience, but also the ability for them to rapidly introduce new products and capabilities. And so there's an increasing amount of pressure on IT to keep up with the increasing demands to accelerate application delivery by the business to the marketplace so they can continue innovating at a faster pace and also improve the overall quality. So we're seeing a fundamental shift in the IT from the development model, from waterfall or agile to one of DevOps. Also in terms of the architecture of these applications that are being developed from a monolithic application to one of microservices, one that has APIs that can easily connect, can be small in size so I can rapidly introduce new products and features with a low amount of risk of having a negative impact as well. And as the application evolves to microservices, it only makes sense to have a packaging or a platform that's complementary to a small-scale microservice, and that's one of containers, right? It doesn't make a lot of sense to deliver an application that's small in size and put it on a 10-gigabyte virtual machine, right? A container is much smaller in size and a great complement and allows you to accelerate the application delivery as well. And so containers are a big part of the promise of accelerating application delivery. And so what you have is because on the left side you have the line of the business and the developers, and they are under increasing pressure to accelerate application delivery. And on the right side you have operations in your security team, and it's really been traditionally a lot of friction between the two sides of the house, because on the right side they're trying to enforce standards and security, right? And they're seen as a bottleneck by the developers because they just want access to the platforms and tools that they need, and they want to be able to accelerate and innovate at their own pace without having a bottleneck caused by these security standards and policies. And so the promise of containers is that they can help bridge the gap between the business, developers, and then operations and the security team, because containers allow you to package the application on its own in a small entity with its dependencies, while allowing a clean separation of the application and the underlying infrastructure, so operations continue to enforce security standards by providing a base image and by enforcing standards on the host level as well. And so Linux containers, right? Linux containers allow you to package your application once and then deliver anywhere, whether it's physical, virtual, public, private, cloud. They allow you to deliver that application and build it in development, and then take that artifact and move it to test and production without having to rebuild it. And the container provides a lightweight isolation of the process, the network, the storage, and the file system as well. And containers have been around for quite some time, but they haven't been popular until Docker came around. And that's because Docker provides simplification and a standardization really in two areas. One is the runtime, and two is the file format. And the simple purpose of Docker is the build, ship, and run. So from a build perspective, similar to a make file in C, you have a Docker file. But the difference is that this is for any language. It's not just Java or C, etc. And the beauty of this is that you can also pull in resources, like I can specify a base image. In this example, I'm pulling the latest Fedora base image. And then I'm able to build that. And another key thing enabling DevOps with containers is the ability to share your images as well. And so once I build my image, I can then upload it into a shared repository, whether it's a public or private registry. And then I can make my images available to any of my environments, public, private, virtual, etc. Because I can then run that Docker image across any of those infrastructures, because there's a standardization of the Docker runtime or the Linux container runtime across all these environments. And that simplifies it and allows me to have the flexibility to deploy anywhere that the business may need. And from a security perspective, I'm able to version control my Docker files. And then in terms of my images, I'm able to set up and store my images either publicly or privately in my own local registry. And then in terms of runtime, I'm able to run it in whatever type of secure environment because of the standardization. And so in terms of standardization, the Linux Foundation came together and created the Open Container Initiative, and really came together in standardizing on those two areas. One was the image format, and two was the runtime. And so they took Docker's standards around runtime as well as the image format, and everyone came to agreement in terms of those being the spec. And now the industry can go ahead and develop their own solutions that meet this spec, similar to the Java J2E spec as well. And so what are the use cases for containers that we're seeing early on from our customers? So I had the chance to talk with many customers in the Valley, and one of the key use cases is certainly around DevOps, also around continuous integration, continuous delivery, maybe on your Jenkins, for example. Also, the ability to match microservices with containers because of that nice low overhead. And another key use case early on with containers is around how we're modernization, right? Taking a legacy application that's still on physical and being able to containerize that, put it on a newer host OS, so I get the benefits of new hardware without having to port my application to a new OS. So I could take, for example, an application today running on RHEL 6, put it into a container, and then run it on a RHEL 7, even though it hasn't been ported over to RHEL 7, the application. And so that's a key use case, as well as availability, real-time scale. Some customers are running Spark in virtual machines for their big data analysis. Well, the challenge there is that as load increases and usage of the Spark cluster increases, they're unable to provision more capacity of their Spark cluster soon enough, and so they commonly have their cluster fail over and crash. By putting Spark in a container, they can quickly start up additional capacity and get ahead of the demand. Also, Diet VM. This is legacy applications that maybe are running on physical hardware or large-scale clusters running on legacy hardware that may need the benefits of containers, but they weren't able to virtualize back in the VM days because there were too much resource overhead, right? So take a look at maybe a render farm or a chip validation job. They didn't virtualize those workloads because the penalty of running it in a VM was too high. But now containers have the promise of having lightweight resource usage, and so they can containerize those workloads, now get the benefits of virtualization. Also, infrastructure optimization, because of the lightweight overhead with containers, you can get higher density of your workload. And in big data, we're seeing customers with large data sets, rather than move the data to where the application is, such as in a university that has different professors across the globe that want to run some sort of analysis on data, rather than ship that data, why not containerize your application and then ship the application to the data? So those are just some of the use cases that we're seeing early on. And there are a lot of security implications for a variety of those use cases. Does anybody recognize some of these brands? All right, these are major brands in the US, some are global, but they also represent over 1 billion record breaches from a security perspective a couple years ago. Right, so these are some major names, and as I polled different companies about what are security risks, number one was employees not taking proper security measures. And then 2, an outside breach. 3 is unpatched or unpatchable, maybe legacy servers there. Internal attack by an employee, shadow IT, and then bring your own device and mobile. So these are some great security risks as polled by your Red Hat and our customers. And when I joined Red Hat, one of the common comments I got from customers, especially in Silicon Valley, when I asked them what are their processes and tools that they're using around patching their servers, they would often say, patch, well, our servers sit behind the firewall. We don't patch our servers, right? And so there's a real need to change that mindset as you adopt containers going forward. Containers have their own set of security risks in terms of kernel exploits. The kernel is higher point of exposure, and I'll talk about a little bit about that. Also, denial of service attacks, container breakouts, poison images, as well as compromised secrets. These are sharing maybe a username password and passing that along to a container instantiation. And so let's dig a little bit deeper on these. In terms of the container runtime, I mentioned kernel exploits, right? In a traditional, on the left side, operating system, you have a single kernel running on a system with your virtual machine, perhaps with virtual machines, and each virtual machine has its own separate kernel, right? So you have a higher level of isolation. But when you go over to a container-based environment, you have a single kernel running across all your containers. So at the host level, it's sharing that kernel with all the containers. And from a security perspective, if there's an exploit in the kernel, there's a risk that all your containers may be exposed. So you want to be careful there about patching your systems with the latest security updates when it pertains to the kernel. Also, when you select what kernel to run. Also, in terms of the underlying technology, what provides this kernel technology? Well, there's really 3 key technologies when it comes to containers in the Linux distribution. First off, about 10 years ago, Google did a lot of work around C groups, so this is really providing quality of service to your environment in terms of a process being limited to a fixed amount of CPU, memory, network, etc. on the system. Also, namespaces, this provides the look and feel to a process or a container that it has a full system. And if you run as root in a container, that doesn't translate to root at the host level as well. So think about from a security perspective, you want to make sure that if there's a breakout from that container to the host and it's a root user, you want to make sure at the host level it also doesn't have root privileges. And then thirdly, SE Linux, right? Most folks probably in your systems today, I often hear that they disable SE Linux. Well, it's very important in a container-based environment that you have SE Linux enabled, because this provides mandatory access controls. And so it explicitly states what a process can have access to on the system. So even if it's root, right, it won't necessarily have access to everything on the system. It'll actually have to be explicitly stated what that process or container can actually touch and have access to. And so Red Hat, we provide SE Linux policies out of the box for a Docker-based environment. Right. And so not only is it about the runtime, but also container images from a security perspective as well. So when you take a look at the container image, that is kind of the file format that a container lives in. Right? Think of a virtual machine has a VMDK or a QCOW format file. Likewise, a Docker container image, and that architecture consists of layers. In Red Hat, we provide base images for containers, whether it's RHEL 6 or RHEL 7, and this allows a nice separation between operations and the developers and provides a base upon which you can build your applications from a developer perspective and have standard libraries, et cetera, to build your application and to have those be pulled in as dependencies into your container image. This separation allows the ability to have security updates as well. So without the developers having to track that and maintain that, instead, the base image can be updated from an operations perspective, and maybe that could automatically trigger a rebuild anytime that base layer is updated as well. So it's important to understand kind of the layered concept around the Docker images. Also, another security implication around images is where are you getting these images, right? Docker Hub, publicly available repository, is a common place. Probably your development teams are already pulling down images into your enterprise. Well, if you take a look at those images, a while back we did a scan of the repository. 64% of them have some sort of security issue, medium or high priority. Right? So you want to be conscious of, hey, I have my developers pulling in these images publicly. Who built those images? What's in those images? Right? Maybe it makes sense for my enterprise to actually have a private registry, right, to control what developers have access, or maybe have a proxy front end so that these are the recommended ones to use, but still proxy over to public in case, so you don't limit their choice as well. And also, once you pull down that image, you can't just forget about security. Right? Let's take a look. This is a diagram showing you the different languages. This is a C application, a Java, Node.js, Perl, PHP. And the orange boxes are showing the different components that are pulled in when you build an application. For example, a C application pulls in Bash and glibc, a Java pulls in JRE as well. And what you may not be able to see at the back there is a little triangle, and it has a number in there. The JRE, it says 66 in that triangle. And what that represents is the number of security notifications there have been for the JRE since RHEL 7. Right? So it's important, if you pulled down or built a container image with the JRE, a year or two ago, you need to constantly be scanning and updating those container images because security issues are coming out on an ongoing basis for these components. And take a look, here is a look at the top 20 vulnerabilities per package. All right, and what's important in the container environment? The kernel, right? The kernel is providing C groups, it's providing namespaces, it's providing SE Linux, and it's being shared across all the containers. So if you're not patching your kernel, you're not paying attention to where your kernel is coming from, right? You're being exposed from an enterprise perspective to security risks, as well as, take a look, Java applications. Look at all the Java packages that have security issues, high volume. Right, so it's important to be aware of, from an operations perspective, what your development team is building for your container. So, what are your options? Right? And this is how I call, security by luck, security by firewall, or a trusted platform. So security by luck is really using unsupported distro that may even be end of life. And this is a common issue and concern in a lot of enterprises. They have a few boxes that are sitting running some applications that they don't have the source code to, or they just want to update on an ongoing basis, and they're running on some artifact or ancient distribution. So you need to be aware of that could be a high risk. Security by firewall, this was quite common when I first joined Red Hat. There's no patch management, using untrusted containers, that's newer, and then also having SE Linux disabled. Right? So in a container world, really need to take a look at having a supported distro with an updated and maintained kernel from a security perspective, having a patch management process and solution, and a culture to patch on an ongoing basis, using trusted containers and the host as well, container scanning, having some sort of scanning process in place. And then putting SE Linux in enforcing mode is very critical so that if a breakout from the container goes to the host, it doesn't impact the host or it doesn't impact the other containers running side by side on that particular system. So let's take a look at, in terms of how to scan your containers from a compliance and as well as a vulnerability perspective. There's an upstream project called Scamp, which provides such a solution. So many of you may be familiar already with common vulnerability and exposure notifications. These are CVs, and they are notifications whenever there's a security issue for a package in the operating system. So if there's something wrong with the JRE or the kernel, a CVE will be issued to notify you that there's a security vulnerability, why it's important, and why it's important to update and how to update it by applying a newer version of that component. Likewise, there's also a common configuration enumeration, CCE database. This provides a set of standards and policies for configuring your Linux system to comply with security standards. Right? Maybe it's having a minimum length of your password on your system configured. And so this content of CVEs, CCEs can be leveraged to scan your systems to see if they comply, both from a vulnerability perspective as well as a security compliance perspective. And so Red Hat produces for its distribution, as well as other distributions, provide a security guide and allows you to check your system. And so the Scamp leverages this content on the left and provides a set of tooling that you can run on physical, virtual, containerized infrastructure. Foreman is an upstream project that provides the ability to scan at scale across a data center. And these scans generate reports for you so that you can assess your infrastructure from a compliance scoring perspective for their compliance scan, as well as a scoring system and a report for vulnerability notifications as well. And so let's take a look at some of the use cases for Scamp. First off, you may be asking, are your password quality requirements set? Are obsolete services enabled, such as Telnet? Is OpenSSH properly configured? Is /temp on a separate partition? So these are common things on a Linux system you may want to check for. And so with the Scamp tool, you can actually run from the command line, in this example, a scan, and it will assess your system of whether it meets or fails these particular compliance checks. So here's some examples in terms of disabling host-based authentication, disabling SSH root login, SSH access via empty passwords. So these are just a few, but the database consists of a full list of different checks that you can either enable or disable. And once you run this scan, you will get an evaluation report showing the results for the target system, and it will provide you a compliance and scoring. And so in this example, you can see that 34 of the checks passed and 33 failed. It's not quite uncommon for a system out of the box to fail many of these checks. And so you want to take a look in your environment. And it breaks it down into high, medium, and low issues as well in the report. And then the report also provides you a detailed view of each failure and pass, which you can drill down on. And it provides the ability to remediate that issue by running a script on your target system. So in this example, it provides the password which failed, and then down at the bottom, here's the suggested script, and I could actually click on a button to rectify this issue. Or I could automate it. Another use case for the OpenScamp tool is to scan for known vulnerabilities. Right? So what RPMs need updating? What is the criticality of this vulnerability? What is the vulnerability? What CVs have not been addressed? So those are those notifications that are published. And so I can perform a scan, just like I did for the compliance. I can do that for the vulnerabilities. And on the right side, I ran on a target system. It looked at all the security notifications to see if I had any non-compliant RPMs installed. And likewise, I will get a report for that target system showing me how many errors for that system. And I can actually drill down, and you can see the security notification issues. So the first ones in the orangish color are issues on that particular system that I need to take a closer look at and apply updates to resolve for that particular system. So this tool not only works on physical and virtual machines, but I also can use it to scan online or offline containers. So online being instances that are running live and instantiated from a file, or that are at rest, not running on a disk. And so I can check to see if the Docker image is compliant, is it patched, etc. And so to do this, I just install the oscamp-docker script, which leverages the underlying OpenScamp tooling. And I can perform a compliance scan using the oscamp docker against the image for offline mode. And then likewise, I can also run it against a particular instance of my live Docker image. And so I can do the compliance scan as well as the vulnerability scan for the live Docker instance. In addition, there is a OpenScamp Workbench. This is a GUI which presents all the different security policies, and I can enable them or disable them for my environment. So this allows me to customize and create a policy that's specific to my environment. There's also an add-on that plugs into Anaconda, the Linux installer. Right? So when I build a system, I would like to run this automatically so that my system from the get-go is compliant. And so that's where the plugin allows you to do that. And here you can see the results of scanning a system or having it enabled or disabled. So on the left, if I just build a system without doing the OpenScamp scan for compliance, it fails on 36%. And here it basically is 100% compliant when I integrate that into the build process. And as I mentioned, Foreman is a solution to run OpenScamp scans across a data center of systems. And so that's an upstream open source project that allows you to integrate OpenScamp into a data center systems management solution. Now, one of the key things in a DevOps world, though, is how do you apply continuous security, right? So containers on their own are great at an individual developer workstation perspective. So that's why Docker has been integrated into the operating system. But there's also a need when you're dealing with containers at scale is to leverage a scheduler and an orchestrator as well, so that you can automate the updating and deployment of containers across data center. And when you think about that from a security perspective, that's really important because in a DevOps flow, I want to continuously innovate, I want to continuously move forward. Right? Gone are the days of going out and patching, for instance, containers in a data center. Instead, because I have an automated build and an automated deploy software factory, I can actually just always move forward. I want to take that container, build it once, and then move it to test, move it into production. If I ever need to replace that, I'll go back to development, build a new version, push it into test, push it into production. I'm not going to go to production and patch something. If I have a process that allows me to go from dev, test into production efficiently. And so that's why it's critical to have in a container-based environment not only Docker as a runtime and an image format, but also ability to automate builds, automate deployment with a scheduler and orchestrator, such as Google's Kubernetes. So Kubernetes is an application management solution for containers based on the experience and knowledge and expertise that Google has built over a decade of their use of containers. They deploy about 2 billion containers a week in their infrastructure. And so they open sourced an application cluster management solution for containers based on the technology internally. And what they open source is called Kubernetes. And so Red Hat's a key contributor and partner in bringing enterprise capabilities to this cluster management solution. And so Kubernetes allows you to effectively deploy a container-based application, which may consist of many microservices. And this is an example of the cockpit UI, which is in the Red Hat Atomic Container OS. And here you can see I have a front end and a back end, and I want to deploy this into my data center. And so Kubernetes will automatically assign a container instance and allocate it to a resource in my environment. It'll IP the address, it'll take care of username, password to connect the front end and back end by sharing secrets. But from a security perspective, if I want this model of always moving forward and not going out and patching my existing containers, I need a real bulletproof and I need a fast and efficient methodology and a set of tooling that takes care of upgrading my environment. And so Kubernetes supports a lot of different update models, whether it's rolling updates or blue-green deployments, et cetera. And so that's where I can have the confidence to be able to release new software, build it, and deploy it quickly. And so with Kubernetes, I can have, for instance, version 1 out in my production environment, which was deployed. My development team can go ahead in a separate namespace, deploy version 1.2, and so they can do some continuous integration testing, maybe using Jenkins. And once it passes that continuous integration testing, I then have the ability to have Kubernetes automatically up the load balancer and redirect traffic to this new version, right? So I can minimize the failover time from the old to the new version. But I also have the confidence that if there is an issue with 1.2, I also have the ability to roll back as well. So we talked about automated builds, but it's also important to have, automated deployments, but it's also important to have automated builds. And so maybe you're using Jenkins today for continuous integration in your DevOps environment. So one of the things you may want to consider into your pipeline is adding a security scan to your continuous integration process, right? So you could leverage maybe the OpenSCAP tool or some other tooling So every time you build your Docker image as a part of your build process, it also goes through a phase of scanning that image to make sure that it's compliant, not only in terms of vulnerabilities, but also your compliance standards that you define. And so those are some things to consider. So in summary, some of the container best practices, only run container images from trusted parties, right? So you need to be aware of what's in that container at all times, not just when it got pulled down, but on an ongoing basis. Likewise, many containers run as root out of the box. You want to make sure you drop those privileges or try not to run your images as root. Host operating system matters, right? It's important that I have a secure, solid foundation and a reliable kernel that's consistently patched, because there's a single kernel across the host as well as all the containers on the system. It's a lighter weight footprint. Also, apply security fixes to your kernel. Right? It's very important to have a process and tooling around that that's automated. Do not disable SC Linux. Right? For the issues and matters that we spoke of earlier, it's very important to have that, and Red Hat provides that out of the box and simplifies the usage of SC Linux. And then on an ongoing basis, make sure you're scanning your images for security flaws, using a process as well as tooling that allows you to do that efficiently and effectively so it doesn't cause a bottleneck in your overall DevOps process. All right, so I want to thank you for attending today's session. Feel free to reach out to me on email, or I'm also available on LinkedIn. If you have any questions, we also have the Red Hat Summit coming up in San Francisco, where you can learn a lot more about DevOps, containers, and container security as well. Thank you so much. Oh, do we have time for questions?
Yep, we have
Yeah, any questions?
a couple of minutes.
Can we extend OpenSCAP for scanning like Apache web server or some database?
Yes, it will scan the entire operating system, so maybe the Apache, it would scan that as well.
But there are some third-party applications like middleware, JBoss. So can we do all that?
Yes, it can be extensible, yes.
Okay, thank you.
Absolutely.
Okay.
Great. All right, thank you.
Thank you very much, Mr. Tuin. Now we have 4 ignites from our 4 distinguished speakers on our agenda. I would like to invite Mr. Derya Sezen, Mr. Berk Dülger, Mr. Zerdal Özdemir, and Mr. Orhan Kalaycı to the stage. And also I have an announcement to make. As you may know, Mr. Hüseyin Babal was supposed to be with us today. However, he has had a baby and therefore is unable to attend the event today. And we wish all the best for the newborn and the happy parents.
Belki ilk başlamak ister misin? Ha?
Hello, everyone. Today I'm going to talk about tactical DevOps adoption and try to bring an example in testing field. Well, my name is Berk Tüger. I'm working for Keytalk Software Services, and in Keytalk we are helping companies to deliver better quality software. I suppose you all know the books George Orwell's 1984 and Huxley's Brave New World. In 1984, Orwell felt that what we hate will ruin us and people will be controlled by the pain. And in the Brave New World, another dystopian novel from a British writer, Huxley, he feared that what we love will ruin us and people will be controlled by the pleasure. I personally believe that we live more in a brave new world. We are controlled by our pleasures. Because the people, we as humankind, learned that to every action there is an opposite equal reaction to our acts. So it's not easy to force people something. We should make them believe in. It's also same for DevOps and Agile. We have to make our managers believe, our colleagues believe, and our self believe also. Because it's a process that requires bottom-up practices and top-down support for long journey. We need to show them value. We need to show the value to everyone in order to make people believe. Because it's a long journey, as I said, and it's a continuous improvement project. In the tactical adoption theory, it hypothesizes that each step towards DevOps maturity should bring a visible business value to the process. And the idea here is that you don't need to bring tools and processes to stack from beginning to end, but seeking the benefit. The reason behind the theory is to encourage make-believe people, practitioners, apply each step and having the benefits in the project. By the way, they will believe in and see the utilities with the proven methodology. There's a perfect example in the verification phase, which is called continuous testing, because basically in Agile, in DevOps world, we release software much frequently and we need more regression testing. And without continuous testing, there is no actual DevOps. This is the test automation pyramid. On the bottom line, there are unit tests. On the middle line, integration tests. On the above, system UI tests. And on the top, there are manual tests, business showcases. There are a lot of different layers, basically 3 layers. And the 3 layers, each layer has different special advantages, disadvantages on business coverage, code coverage, and the cost. I can bring a tactical adaptation example in continuous testing. As you all know, unit tests aims to test small chunks of your tests, functions, classes, in isolation from the rest of the world. But the UI tests, end-to-end tests, where you test the entire system to ensure what it's supposed to run in the real life. You need both of them, but in different times. You need unit tests if you start a project from scratch, and UI tests if you have a code before. And if you have a code beforehand, practically you have a legacy code. Start to get best test coverage with least effort by using the UI tests. Unit tests are also important, but they will bring their proven benefit in the long run. Thank you very much.
Hello everyone, I am Zaldal Özdemir. I am working on Borsa Istanbul and I am on the organization committee too, and I will talk about Jindo, our new shepherd for the microservices. First of all, my agenda is I will talk about infrastructure and applications, which is changing in these years, and I will make introduction for Jindo, and I will talk about these functionalities and proposals for Jindo. First of all, once upon a time we had static infrastructures. We have static infrastructures with happy system admins, lasting, unvarying catalogs, and we have monolithic applications. And infrastructures are changing and changed. In fact, instead of specific local infrastructures, now we have containers, we have virtual machines, containers, lambdas, etc. So on the top of these systems, we have microservices instead of monolithic applications. We have a lot of microservices with different types. And then we have unhappy system admins at the moment, because it will hard to manage these microservices with current technologies. And we have old tools which manages monolithic applications, like in listing servers, listing applications, and showing statically defined applications on the system visually. And we have dependency management problems. We have to change all of firewalls, load balancers, with changing microservices or deploying microservices. It is hard at the moment. And we need better risk management, because one of our microservices or servers or containers is going to fail. We have to find affected applications or microservices. And we propose Jindo. It is developed for the BizTech to complete our DevOps and ease our DevOps infrastructure. It is open source. It will be open source. Every developer can access and integrate their system and make integrations. It is based on it is for the microservices. For Jindo, microservices are the first-class citizens, like in languages. And we are supporting hundreds of microservices to watch and manage. And we can also support external resources like databases, web services, enterprise integrations with the help of Consul, of course. And we have service registry and discovery with the help of the Consul, because we rely on Consul on that side. And we can discover services over DNS automatically. And we propose able to do register details of these services much more. And we have some performance monitoring attached to, integrated to the other tools, and we can gather performance characteristics with integrations. And we have management interfaces for the microservices. We can manage configurations or sensitive informations of microservices for configuration base. And we have support for multiple environments, and we have proposal for supporting dynamical environments. And each environment has different namespace for register and discovery. And for proposal, we will try to control microservices for starting or stopping, or we can use continuous integration services to control microservices, for example, dynamic provisioning, etc. And we have proposal for integrating Docker, Racket, etc. So we can easily complete all of these infrastructures. And in the future, things are changing. We have to be, for system admins and developers, we have to be not this, like this one. We have to be watchful. Thank you all.
Is Orhan Kalaycı out there? All right, can you please come to the stage? buradan başlayalım. F5'e basınca başlıyor. Şuradan. Şuradan.
Nereye basıyor?
F5'e basınca başlıyor.
Başlatır mısın? Hi. DevOps for me is not an easy problem. It is even not a difficult problem. It is a wicked problem. Meaning that these are the characteristics of a wicked problem. So we don't have the definition of like DevOps. What is DevOps? Or it is a social problem that some illogical, unlike technical problems, 1 plus 2 is not 3, but more than 3. That's the complexity increase exponentially. Or we have to bring different departments together. Their values are conflicting. Like, for example, business, development, test, operations, they live in different worlds. They speak different languages. Their values are conflicting. And if you solve operational problems, you may create development problems. If you solve a business problem, you may create test problems. So as I said, DevOps is an ill-defined problem. What is your definition for DevOps? Is this a continuous integration, continuous delivery, or continuous everything? For me, DevOps is actually something beyond Scrum. If an organization is good at Scrum, which I don't believe so many organizations are good at Scrum, because Scrum itself is a wicked problem. If they are successful in Scrum, they may be successful in DevOps. As I said, wicked problems also has boundary definitions problems. It is not clear. For example, is business, should we include in the DevOps teams or not? And again, it is a wicked problem because we have to solve the people problem first. And peoples are working in the questions why. They always ask questions why. Why I have to do this, why I have to do that. So we have to convince different departments to come together, and we don't have answers to their why questions many times. Like business will ask why I have to work with ops, what I have to do with the ops. Have you heard of like this statement, ops from Mars and the DevOps from Venus? They really literally live in a different planet. They speak different languages, they think differently, their values are differently. But not only development and operations live in different planets, actually business and test people are also live different planets. They speak different languages, they think differently, they behave differently, they are from different planets. And in their own planets, they are the king. This is their self-image. They think we are the best. Business people think we are the best. Test people think we are the best. And operation people think we are the best. They are always busy, and they believe that being busy is a good thing. But the other planets may not think they are the best. For example, business people are famous for selling anything for money, including your soul and theirs. And operation people always say no to everything. And suppose we have convinced people to come together answering their why questions, the next questions will be how. How shall we work together? And for example, product owner, if an organization is successful in Scrum, product owner will be highly possible that a DevOps team member. But the product owner will ask, what shall I do? The answer is continuous requirements management. And continuous requirements management requires continuous approval. Going to production requires some approval, and who is going to approve? Product owner, which is business. Business will approve going to production. So the business should be a part of the game. And test automation. Again, it is an how question. Testing will change. The way testing is carried out will be changing. Testers will work in a different way. They don't make manual tests. They develop test softwares. So they become the developers. So we answer why questions, we answer how questions. So we are ready to provide these guys with tools so that they can do whatever they do faster, easier, convenient way. Our tools should be end-to-end, like continuous assessment, continuous delivery, continuous operations. Look the number of screens here. Operations has the most screens and the business has almost none screens. Actually, business is a people business and these guys likely open to more automation. But unless we automate the people problems, meaning customer requirements, if we cannot take the customer requirements and put in the production, DevOps will not work. DevOps will not make the promise by making happy customers. Happy customers means happy requirements. We need to garbage in, garbage out. We need to take the requirements, we need to put the production. And the product owners is not able to get the good requirements, we cannot deliver good requirements as regardless how fast you are. Thank you, that's all.
Hello, my name is Daria. I will be today talking about how to move forward to DevOps culture. I will be discussing with some practices, principles, and also a simple way of moving forward. And the first principle, let's call embrace the change and experimentation. In companies, enterprise, we see obstacle forward this, as we can see there is no fail-safe environment, and the teams are not so much that much empowered to try out new technologies and tools. So, which means no standardization, at least in the beginning. So, by time it will converge. The team or different teams will be trying out new type of technologies, even with the new trend of software architectures, loosely coupled architectures. You can use different type of technologies, even different type of programming languages. Using message queues, there is no requirement to use the same type of technology in the environment. So which increase the flexibility. And also, as you know, ops teams has a different type of role. They have different type of KPIs, which dev does not have. They have mean time to recovery, mean time between failures, recovery time objective, recovery point objective type of, which dev doesn't know what are those. So, which creates a friction between the two parts. So, this which brings also a question about discussing about the KPIs of the different dev and ops teams. So the next principle is automating everything, automating the parts which needs human intervention and which has some way to move forward with some automatization using new trend technologies. So the next one is removing the waste and decrease the oscillations. We have as waste, we may have overbranching in our teams, which we observe, and I personally also observe so much. So why not try less branching, even use or practice trunk-based development. And there are oscillations, yes. Why? Because we